So, in question R.2.15, we are asked to solve an equation. And this particular equation involves some distributive property in the mix. So recall what solve means. Solve means find a value that you can substitute for x that makes this equation true. Find the value you can substitute for x that makes this equation true. That's what we're doing. And how we're doing it is by following the rules we know to make equivalent expressions until we end up with an equivalent expression to this that says x equals whatever. Because when you get to that point, then it's obvious what value of x makes it true. But let's begin. Ordinarily, in simplifying this out, of course, we want to do what's inside parentheses first. And again, the problem is 5 and x are not like terms. We can't combine them, so we rely on distributive property. Then we say that this expression is equal to 1.7 x plus 1.7 times 5. Same thing here, 6.6 and 0.7x can't be combined. We have this negative sign that can be distributed through. Think of it as multiplying the whole thing by -1. So the negative sign can just be distributed through. So we have negative 6.6 and negative 0.7x. So this negative goes through to both of these items inside the parentheses. And then we have -5 plus 2 again. This negative stays just with the 5 because there's no parentheses grouping the 5 and the 2 together, right? Well, now over on this side, we can combine like terms. So we see that there's the 1.7x and the -0.7x are like terms. 1.7 plus point or -0.7, that's equal to 1x. Oh, good. That's going to be convenient. 1.7 times 5 is, well, we better do that first before combining the two additional terms, okay? So we've got 1.7 times 5 is 8.5. And then we still have minus 6.6 equals, and over on this side, we can combine these two already. We have -3. And now we've got these next two like terms, 8.5 and -6.6. We combine them together, and that gives us positive 1.9. So I have 1x is just x, and then 8.5 minus 6.6 is 1.9, and that's equal to -3. We're one step away from greatness, one step away from that ultimately simplified equivalent expression that has x on one side, number on the other. What do we have to do to both sides of the equal sign? Subtract 1.9. Notice I'm not moving things. I am adding and subtracting, multiplying and dividing both sides of the equation. In this case, it's subtraction on both sides of the equal sign. So what's left on this side of the equal sign is x. What's left on this side of the equal sign is we go back 3 and then back 1.9 more steps to get -4.9. So -4.9 is the value that when substituted in for x makes this equation true. Now, shame on me for not checking this in front of you, but if I put in -4.9 in for x, this ends up being 0.1 and this ends up being hard to figure out, but it ends up being where we need it to be. So there's our solution.